Before we do these, let's quickly review our table for sine, cosine, and tangent of 0 through 90-degree angles. So I'm going to do it this way: sine, cosine, tangent, and I'm going to do 0 degrees, 30 degrees, 45, 60, and 90. And again, your quizzes on memorizing these, like as quickly as we would do flashcards, will start next week. Just to give you a little maybe help, for the sine column, as you work your way up, it's root 0 over 2, which is 0. Root 1 over 2, which is 1/2, root 2 over 2, root 3 over 2, and root 4 over 2, which reduces to 1. So if you actually wrote root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2, you would just be able to simplify the first, second, and last. But it does kind of count up that way, which is a nice feature. And the cosine one is just the sine column backwards. So starting with 90 and going backwards, it would be root 0 over 2, root 1 over 2, and since root 1 is just 1, you can write 1 over 2, root 2 over 2, root 3 over 2, and then root 4 over 2. What's root 4? 2 is 2 over 2, which is why that is 1. And then your tangent slowly increases. 0 divided by 1 is 0. And the most obvious ones are the 45-degree angle, because root 2 over 2 divided by itself, anything divided by itself is 1. And then the last one, 1 divided by 0, is undefined. And this slowly increases. So one of these is root 3, and one of them is root 3 over 3. Which one's smaller? We'll go here. What's smaller, root 3 or root 3 divided by 3? Right, because they're the same number except for this one's divided by 3, so it's going to be a third of the size. And this one's just plain root 3. So we need that, and just in case we get radians, because we will, 0 is 0 radians, 30 degrees is pi over 6 radians, 45 is pi over 4, 60 is pi over 3, and 90 is pi over 2. So I put the degrees obviously at the top and the radians at the bottom. Okay. So this is somewhat challenging because honestly there's very little work to be shown. A lot of it is mental. And there's two different things that are going to play into your answer. Number one, the reference angle, and number two, the quadrant that this is in. So if you were to quickly sketch 240, what quadrant would that land in? The third, right? 0, 90, 180, 270 would be too far. So that would be 240. And what's the reference angle? 60, because here's 180, and we're 60 degrees past. Very good. So a couple things. The quadrant is quadrant 3. Is sine positive or negative there? All students take calculus. So is sine positive or negative here? Negative. So the quadrant tells you whether your answer is negative or positive. The reference angle equaling 60 tells you which value to grab from your table. So if you're taking the sine of 240, it's going to be the same as the sine of 60, give or take the minus sign based on the quadrant. And what is the sine of 60? Root 3 over 2. So the sine of 240, because it has a reference angle of 60, is also root 3 over 2, but with a negative sign based on the quadrant it fell in. Does that make sense? So evaluate the quadrant will tell you whether it's positive or negative first, and evaluating the reference angle will actually give you the numerical portion. Okay? So 330, what quadrant are we in? So Q4, is cosine positive or negative there? Positive. Did everyone see that? With the C there? And then what's the reference angle? Okay, reference equals 30, and we're taking the cosine. So what's the cosine of 30? Root 3 over 2. So there's your answer. The cosine of 330 is root 3 over 2. Good? Let's go around the horn here. Jason, what quadrant is 135 in? 2. So Q2. And then Bella, is this going to be positive or negative? Okay, because quadrant 2 is here and only sine is positive. We're taking the tangent. Correct, so it should be negative. Jack, Birmingham, reference angle. 45, very good. And then, so what's the value, Faye? 1. Tangent of 45 as your reference gives you 1. So the tangent of 135 is negative 1. Good? Now we're just jumping to radians. So kind of shift the way you're thinking. Lucas Coletta, what quadrant is 5 pi over 6 in? Lucas, if our denominator is 6, how should we label this? 6 pi over 6. So by that logic, and using my bobby pin, it is in quadrant 2, right? 0 pi over 6 to 6 pi over 6. So 5 pi over 6 is going to be like one tick if you think of this as like a clock. 5 pi over 6 is going to be Q2. So, who am I at? Owen, is this sign, since we're in quadrant 2, going to be positive or negative? No. All students, sign is positive. Reference angle, Angie? Yes, I want, if it's in radians though, I want you to mentally keep it in radians. So the difference between 5 pi over 6 and 6 pi over 6 is pi over 6. So the reference angle is pi over 6. And if you go to your chart, Morgan, what is the numerical value? Sine of pi over 6 is 1/2. Vince, what quadrant are we in with 5 pi over 4? Very good, because this is 4 pi over 4. So 5 pi over 4 would be one tick past that. So Eric, is this going to be a positive or a negative? All students take, right? So only tangent would be positive. So this is a cosine, so that would be a negative. Reference angle, Haley? Pi over 4. And so the numerical value, Natalie? Root 2 over 2. Very good. Who's getting nervous over there on that side of the room? We're coming for you. Nobody. 7 pi over 3. Lucas B. What quadrant? Nope. If it's pi over 3, how would you label this one? 3 pi over 3. And how would you label, if you kept going around a full circle, how would you label this one? 6 pi over 3. So quadrant 1. Very good. So that's 7 pi over 3. So Q1, which means, Alexa, positive or negative? Everything's positive in quadrant 1. That's nice. And then our reference angle, Chloe? So what is the value? Very good. Tangent of pi over 3 from your table is radical 3. This is nice and easy to grab the value, right? Because you have the table sitting in front of you, but you're not going to have the table sitting in front of you, which is why I'm going to require that you memorize all these as quickly as your times tables. All right. Moving on. Corey, what quadrant are we in? I don't think so. The denominator is 4, so how should I label this? Okay. And so if I keep going, what's this? Oh, it's negative. Sorry. So this is going to be, we're going to go backwards. Maybe you were right. Were you right? Sorry. So negative 4 pi over 4 and negative 8 pi over 4. What did you say? Did you say first? Oh, you're right. It is the first one. All right, so we were both wrong. That feels good. What encouragement, Mrs. Rahil. We were all wrong. We missed the negative. So we went backwards. Negative 4 pi over 4, negative 8 pi over 4, so negative 7 pi over 4 would have been one tick before that. So is this positive or negative, Georgia? Positive, because we're in the first quadrant. Q1. And what's the actual value? Jack T. Very good, because the reference angle is pi over 4, and the sine of pi over 4 is radical 2 over 2. Good? Cosine of negative 180. What quadrant tests? Maybe a trick question? Describe the location of the terminal ray. On the x-axis, that's 0 degrees. We're at negative 180. Okay? So this one's a little bit tricky because if you're not in a quadrant, how do you determine positive or negative? Okay, so that is a little bit tricky. So we're going to talk about that now. All students take calculus. What is the reference angle, Chris Brooks? What is the angle between the terminal ray and the x-axis? 0. So what is the cosine of 0? 1. So we know the value is 1. The question is still, because it wasn't in a quadrant, is it positive or negative? What is cosine here? Negative. And what is it here? Negative. So it's truthfully, it's negative in this entire section. So that's negative 1. If it were to be on this one, cosine is positive on either side. So the cosine is just going to continue being positive this entire stretch. Yeah. Gotcha. Yeah. I'm going to give you one quick thing about sines and cosines, hopefully, before we leave today. Last one. Tangent of negative pi over 6. What quadrant are we in, Mike? Yes, because we're just going backwards, and we're barely going backwards, just negative 1 pi over 6. So Q4 means, are we positive or negative here, Sierra, with a C? Negative. Because only C should be positive here, so tangent is negative. And what's our numerical answer? Sierra with an S. Radical 3 over 3, because the reference angle is pi over 6. Okie doke. All right, we're going to talk a little bit more about those quadrantal angles in a minute, but let's get through these. Terminal ray of an angle, drawn in standard position, falls in the second quadrant. Draw it. Draw a terminal ray falling in the second quadrant. This is just like last night's homework, yeah? Second quadrant, terminal ray. What do we always do after we draw the terminal ray? Drop the altitude for a triangle, very good. Here's your angle, and they're telling us that sine is 3/5. So, oh wow, that ended up perfectly. We got everybody there. So if the sine is 3/5, what am I labeling here? Chris. Good? Right, sine is opposite over hypotenuse. And you should be familiar with certain triangles without doing the Pythagorean theorem, and this would be one of them. George, a question or an answer? Because they told me it was. That's okay. Natalie, what's this going to be? Opposite. No. Here's your angle. This is the opposite. Adjacent. But I'm asking you what's the numerical value of it. How am I going to label it? 4, but it's in the negative direction. So positive 4 would be that way. This is going to be negative 4. A 3, 4, 5 triangle should be, there's a couple Pythagorean triples you should know. When the hypotenuse is 5, 3, 4, 5. When you have 8, 15, do you know what the hypotenuse is? 17. Any family of 3, 4, 5, like 6, 8, 10 as well. So that can just save you time. But the tangent, now based on our picture, Angie, would be what? Very good. 3 over negative 4, which is the same as negative 3/4, right? We do need to be aware that if this was a multiple choice, even though we see opposite over adjacent and the negatives is clearly in the denominator, this does equal negative 3/4, and it also equals negative 3/4. Whether the negative is solely in the denominator or solely in the numerator or out in front, that's all the same value. Good? And the cosine would be what, Alexa? Adjacent over hypotenuse. Beautiful. Okay? This is just going to be like last night, so let's pass that for a second and go down to here because I had a point to be making here. When you compare an opposite leg over a hypotenuse, which one's always bigger? The hypotenuse. So if you have a fraction and you're guaranteed that the numerator will be smaller than the denominator, what value will this never get up to? Like if you have always a smaller number, whether it's 5 over 6 or 500 over 501. 1. Okay? The sine of any angle will never be bigger than 1. And it will never be smaller than negative 1. Has to be between negative 1 and 1 for that reason. Okay? So really the value has to be between 0 and 1, but because we know sometimes it's plus and sometimes it's minus, it's between 0 and 1 or between 0 and negative 1. Okay? And the same thing is true for cosine, because that should say adjacent. I wonder how many years that's been. Oh, geez, I must have copied and pasted. But anyway, adjacent is a leg over a bigger hypotenuse. So for cosine, it's going to be the exact same thing. Negative 1 to 1. And tangent is opposite over adjacent. Now that can go either way, right? The opposite leg could be bigger than the adjacent, or the adjacent leg could be bigger than the opposite. So there's really no restrictions on tangent. It will go from negative infinity to infinity. That can go any way. Okay? So, wait one second. here's my thing on this quadrantal angle, and I'm going to show you something that you have to know. So in our table, and I'm going to do sine values, okay? Our table only gives us 0 to 90, correct? And the sine of 0 is, no. The sine of 0 is 0, and the sine of 90 is 1, right? And all those critical angles in between kind of gives you values that climb up to that. So this is root 1 over 2, 1/2, root 2 over 2, and root 3 over 2. Our table gives us that. The sine of 0 is 0. The sine of 30 degrees is 1/2. The sine of 45 degrees is root 2 over 2. The sine of 60 degrees is root 3 over 2. And the sine of 90 is 1. So maybe visualizing this will help you as well with your memorization. But once you get out of that quadrant, if you're in between in other quadrants, it's obvious to know that all these signs are positive, all these signs are negative, and all these signs are negative. But as far as the quadrantal angles, like the negative 180 degrees that we looked at, if this is 0, the opposite pole is also 0. So the sine of 180 degrees is also 0. On this pole, like this being the north side and this being the south side, if the sine of 90 is 1, then the opposite pole is going to be negative 1. Do you see how it's, because it's sandwiched between two negative sign quadrants? Does that make sense? Okay? And I want you to memorize the same thing kind of for a cosine. So a cosine is the reverse of a sine. The cosine of 0 actually starts at 1 and reduces down to 0 when we get to our 90-degree angle. And everything in between slowly increases. So this one was root 4 over 2. This is root 3 over 2. This is root 2 over 2. This is root 1 over 2. So maybe visualizing how sine starts at 0 and increases up to 1, whereas cosine starts at 1 and it decreases down to 0 could be helpful. Okay? But also when you get to these quadrantal angles, cosine is positive here and positive here, but negative here and here. So if this is 1, if the cosine of 0 degrees is 1, then the cosine of 180 degrees on the opposite end is negative 1, which makes sense because it's sandwiched between two negative cosine quadrants. And if the cosine of 90 degrees is 0, what's the cosine of 270 degrees? Also 0, because what number is sandwiched between negatives and positives? 0. So it kind of can make sense from that angle too if you like that. All right. Homework. Keep setting those flashcards. I think moving forward, yes, the trig value ones, but also your vocab ones. I think rather than doing homework quizzes most every day, and I forget to do the vocab quizzes, I think one of the issues on the midterm is that I hadn't reviewed like those vocab flashcards or made you study them in a long time. I think I'm just gonna like completely random try to have it be almost like a 50-50 split, whether you're taking a homework quiz when you come in or whether you're taking a flashcard quiz when you come in. So put it on your regular agenda every night and just look over your vocab, because I'm going to try to keep it pretty even. Not necessarily every other day, but I'm going to try to keep that even.